last lesson we looked at permutations, so when things are given a specific order or we're arranging the thing.
Kidding me? You could smell it like starting, couldn't you? You like walk in. We just started. We were waiting for you guys, and just as we started, you walk in.
Oh. If we're late, we don't expect you to wait for us.
Right, so last lesson we looked at permutations, so where we have things arranged in a set order. Okay, that's the permutation. And we also considered permutations with repeating elements. So the word thereafter, I think, was what we did last lesson, where we had the same letters repeating, but it still made the same word. So we had to consider taking away some of those arrangements to because of the double and tripled up letters. So that's almost along the lines of what a combination is. Okay, so basically combination is when we arrange things without a specific order. Okay, so for example, if you're going to form a committee and you're going to have 2 boys and 2 girls from your year group, okay, it doesn't actually matter the order of the 2 girls and 2 boys in to form that committee. Okay, so that's a combination. So suppose we ignore the order in which the R objects that we've chosen from our pool of N objects. So we're going back to your permutation. We had a total pool of N objects, so 8 people in a line, for example, but we wanted to know the first 3 people, how many ways that could be arranged. Okay, that was a permutation. So that was 8 people N and 3 people R that we specifically wanted to look at. Okay, so we wish to find the number of ways of choosing a collection of R objects from a collection of N objects. Okay, so we're talking about N and R notation again. So one way to do this is to note that choosing is to note that choosing an ordered sample is equivalent to choosing an unordered sample, then we order it. Okay, so when we order a sample, we have a permutation, and when we have an unordered sample, we won't have any specific order in the way the people or objects are arranged. Okay, so notation, so N, C, R. That's really first from last lesson, N, P, R, which was N factorial over N take away R factorial. That was our notation from last lesson, and we can use our calculators to do our P and C calculations rather than doing all that factorial business there. So a combination, so that'll be C. Okay, so N, C, R, which will be similar to the permutation, but when we are not concerned about order at all, so like last lesson when we had the word thereafter and we had the repeating letters, okay, we actually divided the number of possible combinations by the factorial of every letter that repeats twice, 3 times, so forth. Okay, so when we are not actually concerned about the order, we're also going to divide by R factorial. Okay, when things do not have a specific order. Okay, so you're forming a committee, okay, or you're going to pick 5 cards and have them in your hand, okay, when you're not concerned about the order. Alright, we have to reduce the combination, not the first card you pick is this, the second card you pick is this, okay. What do you have in your hand of 5 cards there? Okay, so that is the notation. Okay, again on the calculator, it's next to the P button on your calculator. You have to do the same sort of thing, so shift, whatever the button is for C, so you put the number first, shift, then push the button C, and then your value for R and equal, and that will give you your calculation. Okay, so the proof is similar to what we did for the permutations, so I'm going to leave it at that. Now the special case, so we have N, C, N, which is equal to 1. Okay, so for example, if you have 6 boys and you wanted to select a committee of 6 boys, and how many ways that can be done? Just one, because everyone's picked. Okay, we're not concerned about who's first, second, third, fourth, fifth or sixth in an array. You're just concerned about who's actually in that group. Okay, that's the difference between the permutations. So the order, so if you had 6 boys in an array, first, second, third, fourth, fifth and sixth. Okay, so you can have a number of different arrangements there. And combination, if you just want those 6 boys into a committee, okay, of 6 boys, how many ways that can be done? Just one, because there's no definitive order in that procedure. Alright, so proof 13.5. Okay, so all it is just a matter of substituting n in for r here. So n c n, which is n factorial over n take away some r. So my value for r is n. So n take away n factorial, and then r is now n factorial. Okay, so n factorial and n factorial cancel. And you're left with 1 over 0 factorial. And remembering that 0 factorial is 1. Okay, if you don't remember that, if you put in the calculator 0 factorial equals, and it'll give you 1. Okay? Right, so again, a permutation when we order things, a combination is when things are not ordered. Okay, so ordered permutation, unordered combination. Okay? Now, is there any questions about the interpretations of permutations and combinations before we try some examples? So, one of the biggest challenges you guys will face in your questions, obviously today we're looking at specifically combination style question, okay? But when you do a revision exercise or you do an assessment and you have a permutation or combinations question, the first thing you need to be able to recognise is, do I have a permutation or do I have a combination? Okay, if you're going to use one of these formulas, or like last lesson where we had to draw a diagram and then work through your diagram where we didn't actually use any permutation notation. Okay, but that's one of the things you need to do is to be able to work out how you're going to approach the question and then find out the total number of arrangements, or from that find out the probability of some favourable outcome. Okay, so when order is important, a selection is called a permutation. So for example, people in a line, when order is not important, the selection is called a combination. So for example, people in a committee. So note again, you won't always find it practical to use formulas. Okay, so sometimes drawing a diagram and working out patterns from your arrangement would be a better way to answer questions than just straight formula there. Alright, let's look at some examples. Okay. So, let's find the number of ways that I find the number of combinations. So there's the big hint, it is combination, we're not doing any permutation. That selecting 6 numbers in a 40 number lotto draw. Okay, so when you play lotto, you don't need your numbers in a specific order, you just need to have the numbers that you selected. Alright, so combination. Alright, so there's 40 numbers in the pool when lotto gets drawn, but from that you want to have 6. So in other words, how many different combinations of 6 numbers can be pulled out of this draw? $3,838,380. Okay, just picking 6 numbers out of 40, there's over almost 4 million different ways that can be done. Now, try this. Try the permutation. Go 40p6. So if you had to have these numbers in a specific order. If So if you needed the numbers in specific order.
2 billion. 3 billion.
2 trillion.
230 billion. I don't know.
Yeah.
We don't even know what
It's
the number is. 276 trillion, 3 billion.
No, 2 trillion.
2 trillion.
2 trillion, 700.
We'll round to an inch trillion, 3 trillion.
Oh, wait, no, 7.
So
No.
the takeaway of that is that there will always be more permutation possible arrangement than there are combination possible arrangement. Okay?
Still a lot of.
And that's what, can someone just do, did anyone try 18 factorial?
Yes,
What was the number?
It's 6 point a whole lot of numbers times 10 to the power of.
What was the power?
Yeah,
I think it was 10 to the power of 5.
15.
No, factorial.
So billion, million 6, a billion 9,
Yeah,
a trillion's 12, so whatever's after, what after a trillion?
Do we even know?
Did that in PTS, I was like,
PC,
I'm sorry.
So, if every single person in Australia picks a list of those 18 placements, there will still be left over, well and truly. Like if everyone picked 2, if everyone had 2 different arrangements, if everyone was different, there would still be leftovers.
What if they like automatically rolled out a lot of them because some people would be bad?
What do you mean?
So like a lot of the combinations could be with the really bad teams at the top. What if they rolled out half of them?
Oh, okay, yeah, well, if you knew your sport and you knew a team wasn't going to finish up there, you could probably reduce your possible arrangements there. But, yeah, it really does blow the mind how many, the numbers that are coming back, okay, and why why betting agencies are able to promote things like this, because people just don't understand the maths. They think it's easy to pick a list of 18 teams in order, how they're going to finish at the end of the year for $5, and you're going to get $100 million, I think he said, back if you get that right. Right, well, look at the odds. You're pretty slim.
This needs to be taught. Like,
No, it
it's
doesn't.
compulsory to be taught.
No, because then you can take advantage of it.
And then if you're someone that will give every single possible combination, so you've got 10 to the 15 times $5 per bet, you're just losing money there, aren't you? Okay, B. Alright, so I've talked about committee a lot, so here we've got an example here. Then how many ways can a committee of 3 women and 5 men be selected from 8 women and 12 men? Okay, so you'll have your year group captains, vice captains coming up soon. Okay, so this will be more of an order, because you have got someone who's going to be specifically a captain and someone who's going to be specifically a vice captain. But then you have the rest of the SRC, for example, okay, which are going to be selected from 3 girls, 3 women, and 5 boys, 5 men. Okay, from 8 women and 12 men. So how many ways? So arrangement. So we have 8 women and we need to pick 3. Okay, the order is not important, we just need any 3 in there. We're not concerned about who's going to get picked first, second, third. Okay, just who's in that committee. Now we need to add the arrangements for the men. So we have 12 total men to pick from, and from that we're going to pick 5. Okay, so it's 8C3 plus 12C5. 848. Okay, so this is really, if we were to consider the arrangement, okay, so we've got 3 women and we have 5 men, okay, so we considered the actual mass from 8 of them, so any 8 could be in that first woman picked, then the remaining 7, any of those 7 can be picked for that second place, and then the remaining 6 can be picked for that third place. Alright? Now the difference between a permutation and a combination is that we are not actually concerned about that order, so we would divide that by 3 factorial in terms of we're not concerned about the order at all. Okay, so like when we had the doubled up letters, we had 3 letter E's in the word thereafter. Alright, so we divided that by 3 factorial. Alright, and then that's the difference between a permutation and a combination. Alright, so like here, so 12, 11, 10, 9, 8 divided by 5 factorial. Again, we weren't concerned about the order. So that's the maths there that's involved in that. So if you can't work out if it's a permutation or combination, you need to start drawing diagrams and start recognising some pattern and considering what the conditions are for your arrangements. Alright, C. In a game of Texas Hold'em poker, players are dealt with 2 cards. So how many possible hands could one player have? What's the maths?
54
So,
cards. Is it 52 cards in the deck?
52 cards in deck.
Play the Joker?
And you need to know that, okay? You need to know there are 52 cards in the deck.
If they're playing poker, you don't play with jokers in poker. 60 jokers.
So 52 playing cards, yeah.
Oh, so there's 50.
So you take away, you remove the jokers unless you're told specifically that there are jokers. Okay? Jokers are removed unless you're told specifically they're there.
What's the movie where the maths teacher makes them gamble and then when one gives it money?
Alright, so what's the maths? What's more working?
No combinations.
52 C, and counting.
We need 2. Okay, so from those 52 cards, you can have any 2 in your hand. And again, you're not concerned about the order. Okay, you're not needing a specific card first and then a specific card second. So this is a combination. All right, what do we get? $1,326.
Yep.
Okay, so looking at it without the notation of combination. All right, so you've got 2 cards. All right, so how many ways could that first card be? How many arrangements for that first card? That draws out of the pack? 52. How many ways can that second card be? 51. Now, if the order was important, you need a specific card first and then a specific card second. That's the permutation. So it'll be 52P2. But for a combination, when you're playing poker, you don't need a specific order of cards in your hand. Okay, so because of that, we divide by the number of cards factorial, which is where that 2 comes in. Okay, so you can have from 52 cards and having 2 in your hand, you can have 1,326 possible cards in your hand. Okay? Now, this would be different if you were told about the conditions of who else is playing, like in terms of how many other people are playing, and then you're told about the dealing out. Okay, so that's something you'll have to consider for your question if you are told that in the future. All right, any question? Is everyone following sort of what's going on, the difference between a permutation and a combination? Good? All right. D, a team of 3 athletes is to be selected from a squad of 8. Okay, a team of 3 picked from 8. Part I, how many different teams can be selected if they are so that they are ranked in order of age from 1 to 3? Okay, they are ranked in order from age from 1, 2 and 3. So first, is this a permutation or is this a combination? Permutation, we have an order, okay? So from a team of 8 athletes, we have a permutation, we have a set order. We want to rank them from age or ability or height or something, that they're either set order. All right, and then from that we need to pick 3 of them. Which is really, if 8 people ran a race, in how many ways could the first 3 place getters finish? 336. How many teams without regard to order can be selected That's I, double I. So how many teams without regard to order could be selected? Okay, so we have a combination. There is no, you're just picking 3 people to put on the plane to take over to the Olympics. Okay, you're not concerned about order at all. All right, you just want the number of arrangements. Okay, and remembering your number of
I said I reckon there'll be about 50, and Robin said 58, and it was 56.
Yep, very good. You're thinking about your answers. Excellent. Now, also, like I've said before, the take home this as well, that there will always be a larger number of permutations, significantly larger than the number of combinations. Okay, so you're also looking at your answers. I know sometimes it is really hard to comprehend. So for example, if you get 6 numbers in a pool of 40 in a lotto, you're still almost 4 million combinations. Probably seems like a lot, but the math, if we were to do the math properly, okay, it's 40 times 39 times 38, and then divide by 6 factorial, because we can have them in any order we want. Okay, but looking at your answers and checking that they are reasonable for your answers for the question. Okay, so if we had 8 people in a specific order, 336 will start to become more reasonable once you have some more exposure to the question. But picking 3, any 3 from those 8, 56 different ways that can happen. All right, any question? All right, last one. All right, so what is the probability? So we've just talked about arrangements, okay? So we're just listing the possible number of things that, ways that can happen. Remembering probability is an application of your arrangement, okay? So you also need to consider the whole possible arrangement on the bottom of your fraction, and then on top of your fraction the number of favourable arrangement. All right, so you have a hand of 5 cards. So playing cards. Again, you're not told about jokers, so you assume that they are out. All right. So, what is the probability that a hand of 5 contain? We have 4 aces and 1 other card. Okay, 4 aces and 1 other card. Okay, well, let's do probability. Right, what will go on the bottom of the fraction?
How many things are also?
Yes? So how many ways can I, from a pack of 52 cards, have 5 of them? What notation do I need to write for the bottom there? Combination or permutation? Combination, because you're not concerned about the order at all, okay? So what do I write for my combination there?
52C5.
Good, okay, there's 52 cards. 52 cards in the pack, and you need 5 of them, okay? So 52 C5. Alright, now thinking about how many hands you can have that contains 4 aces out of 52 cards. How many are there? And this is where I got a bit undone yesterday and the day before when I tried these questions, and now it makes more sense. Alright, so how many hands of 5 cards can you have that consist of 4 aces?
9. 1, yeah, 52. No,
Okay.
1 player. 48.
Good. Why 48?
Because the 4 aces are taken.
Okay, so you need 4 aces. So you need a specific 4 cards, but you need a 5 card hand. Therefore, any one of the remaining 48 cards will still give you those 4 aces that you need. Okay? So, you're either doing shorthand So you realise that there are 48 possible cards, right? Or if you want to treat that like a combination style question, you need 4 aces. So from the 4 aces that are in the deck, you need all 4 of them. So there'll be a 4C4, in other words, which is 1. Okay? And then from the remaining 48 cards, you need 1 of them. And because the order is not important, it doesn't matter how you get those as long as you've got your 4 aces in your hand. Okay, so they could be the first 4 cards out, it could be the first, 3rd, 4th, 5th, okay, it could be the last 4 that are drawn out, okay, we're not concerned about the order at all, okay, so that is why it is going to be a combination style question. Alright, so what's the probability?
1 over 5, 4, 1, 4, 5.
5, 4, 1,
4, 5.
4, 5.
5, 4, 1, 4, 5.
Is there another number?
No, that's the lowest.
That's rounded.
Yeah, that's the
No.
lowest common denominator.
Oh yeah, that's fine. Yep. So 1 over 54,145.
Yep.
Right, so if you're playing poker in real life, having 4 of a kind is your second highest hand you can have. Okay, but the odds of getting that is still still greater than 1 over 50,000.
That's massive. Yeah. Yeah, and or would they like play the game?
Is everyone familiar with how poker's played?
Yes. Kind of.
Okay,
They
basically
play
there's
the
2 main forms of it, okay? Basically to win a game of poker, you have 5 cards and you've got to have the highest hand. Okay, so they come in pairs, so you have a pair of cards, you have triple of a card, you have 2 pairs of a card and so forth. Alright, there's 2 ways that can be played. Alright, you have a table around, you have different players and everyone is dealt 2 cards to start with. Okay, and then a round of betting will go down and then 3 cards will be laid out in the middle of the table and they're communal cards. Okay, so at that stage everyone has 5 cards. They've got their own 2, which distinguishes the strength of hands from each other, as well as the communal 3. Okay, from that a 4th card will go from down there after a round of betting, and then after another round of betting a 5th card will go down. Okay, so on the table, if you're still in, there are 5 cards and you still have 2 in your hand. Okay, so you need to have the best 5 card hand, out of the 7 that are out there. Okay, the other way you can play it is what we're looking at now. If you have 5 cards, okay, you are then allowed to discard cards and then get redrawn the same number of cards you get discarded. Okay, so if you wanted to discard 3 cards, okay, you'll then be given another 3 from the deck. Okay,
Can we play poker?
okay,
Can we play poker?
we can play poker. Yeah.
It doesn't matter about it.
count cards.
That'd be cool.
Yep, right. Yep, right. So, that's 2 main ways to play, but the whole aim of it is to get the best strength of your 5 cards that you have. Okay, now the second highest one you can have is what's called 4 of a kind. So you have 4 of the same number or 4 of the same Queen, King, Jack, Ace, etc. Okay, that is the second highest hand you can have. Alright, which is 1 over 50,000, greater than 1 over 50,000 chance of getting that. Okay, now if you were just focusing on a pair, then you might have a pair of 10s for example, which is a weaker hand, but at least you've got something, but the probability if we were to calculate it would be much, much less than that. Okay, because you're only concerned about 2 cards for example, alright, and that can be any 13 different things you can have from that.
Is the royal flush higher or
The royal.
full house?
The royal flush is the highest. Yep. Yep. Alright, we can organise a maths lesson around that.
I used to play, when I was
Next week.
play with mum, we had this massive bag of like 5 cent pieces.
Alright, double I. Okay, so another combination. This one, no. Alright, so you've got 2 spades and 3 clubs. 2 spades, 3 clubs. Now this is not actually a winning hand at all.
Or
Not an actual poker hand. Okay, but we need to decide how many arrangements there are. So, again, probability. 2 spades, 3 clubs equal. So let's first consider what goes on the bottom, how many total possible combinations there are. What's the notation, not the number? Yep. Okay, so from 52 cards, you need 5 of them in any order.
No, but aren't you doing but they have houses, you know what I mean? There's spades and clubs, it's not just any club.
It has to be specifically 2 spades and specifically 3 clubs.
Okay. Alright.
Alright, so what's the notation that'll go up on top? Any ideas?
Oh, it's 13.
Yeah, 13, sorry.
Good. There are 13 cards in a suit. There are 4 suits, which gives you total 52.
13C2 plus 13C3.
Times. 13C2 for your 2 spade. Then you need 2 spades out of a possible 13 in any order, and you need to multiply it. Okay? Multiply by 13C3. You can have 3 spades in any order, whatever order that's dealt with, as long as I've got those cards. Right, what do we get?
143 over 16,660.
16,660.
60. So 16660.
Should be able to simplify further.
No.
140 what? 3 is it?
Yeah.
Oh. Alright. Triple I. 2 jacks. Okay, which is the pair? Which is the lowest hand you can have. 2 jacks. So it goes pair, 1 pair, 2 pair, 3 of a kind. Straight, which is 5 cards in a consecutive order. So it'll be like 2, 3, 4, 5, 6 of any suit. You have what's called a flush. So you have 5 spades, 5 clubs, etc. You then have what's called a full house, which is a combination of 3 of a kind and a pair. You have 3 of one card and a pair of another. Okay. You then have your 4 of a kind, so with the aces. And then you have what's called a straight flush. Okay. So you have 5 consecutive cards, all of the same suit. So you have 2, 3, 4, 5, and 6 of hearts. Okay. And then the higher you have, the best card you have. So the royal flush is the 10, Jack, Queen, King, Ace of the same suit. That is the highest hand. So, in retrospective, you're more likely to get a pair of jacks than you are to get anything higher than that. Right, so the probability, 2 jacks. So, how many total combinations are there? What's the notation?
2C4. No, 4C2.
No, for the bottom, sorry, first.
Sorry.
So 52, you want 5 of them. 52C5 possible combination. Alright, so yes, 4C2, you need 4 of those. 2 of the 4 jacks.
we did the 5
Because it still hasn't been even 5.
because you're still working out a probability of your 5 cards from 52.
Yeah.
Alright, is that it?
And times is...
You still need another 3 cards. Okay, so even though you got your pair, you still are dealt another 3. So how do I notate those other 3?
50C3? No.
Okay.
50C3.
Yes, however, you're on the right track. However, you're told specifically 2 jacks. Okay, so if you say 50C2, you still got the chance of getting another jack. And you want specifically 2 of them. You have to take all the jacks away from your deck. Yes. 48.
11.
So you need another 3 cards from the remaining 48 because you do not want, or the question does not need another jack. Okay, so what's that one?
Just a couple of thousand.
It's, 2,162 over 54,175.
Wait, 2,162.
2,162.
2162 over.
At 54,145.
Now, Mr. Smith, good timing.
Same denominator as the rest of them.
Oh, but some of them can be simplified,
I'm
yeah.
sorry that you just did that in your head.
Yeah, I know. It's scared you all, didn't it?
Now,
Sometimes take the easy option. Don't do the math.
145.
So, good timing. The question I said to them, we needed 2 jacks. Okay, so we have 4C2, but you cannot then say 50C3 because you can still get another jack when you specifically need 2.
Yep.
Yep. Okay?
Educational purpose.
Yeah.
And now we're
Yeah.
We are...
on Wednesday morning next week, we're playing poker.
Cool.
Do you want to
Oh yeah.
Yep, you're coming.
Oh yeah.
We're having a math lesson.
I played this game with my Year 8 class a few years ago in Sydney, and they desperately wanted to play for money. I'm going, nah, can't play for money. And they went, no, we won't. I was like, all right, 5 and 10 cent coins only. And so they bought this massive pile of 5 and 10 cent coins, and it took me 2 lessons, and I had everybody's money.
How much did you end up?
I had to give it all back. I was just thinking about it, and I was like, have you learned anything?
But how much did you end up?
Oh, it's probably over $100.
Do you want me to bring in 5 points?
Yeah, like they seriously
No,
bought in like their life saving
Yeah.
5 and 10 cent coins. It was
Do we
ridiculous.
have chips?
Do you have
I've got
chips?
chips, yeah, so I'll bring them in.
Because I can bring in 5-cent coins.
No.
I can bring in
Chips.
Well, if
Chips.
everyone does it, we can do it, but
I've used
Chips
coins
are
to
good.
work,
But
don't worry.
chips are easy.
Chips are fun.
Yeah, exactly.
Especially when you like...
alright, that means I'll probably have to come pick you up on Wednesday morning.
On the cards.
Alright, done. Poker, Wednesday morning. And yes, there will be a math lesson associated with it.
Of course.
Alright,
And possibly a
Oh, I
YouTube
thought you
video.
said done.
alright, probability at least 2 jacks. So note the difference between those last 2 questions. You asked the probability of getting specifically 2 jacks. Now you have the probability of getting at least 2. So if you get extra jacks, it means your hand strength has increased. So if you get another one, you have 3 of a kind, which is higher than 1 pair, sorry.
Is it just the same but 50C3?
Sorry,
It's just the same but 50C3.
That's part of it.
part of it, not all of it though.
There are 2 ways to look at this question. Neither of them is really that much shorter than the other.
No.
You've got to identify what are the hands that can even meet this. So in the case of at least 2 jacks, it means the one that you just worked out, which was the probability of 2 jacks, is also what you worked out in part 1, which was the probability of 4. Now it was 4 aces, but the probability of 4 jacks is identical. And you also need to cover the possibility of 3 jacks, because all 3 of those meet that at of each of those, and because it's 2 jacks or 3 jacks or 4 jacks, the or indicates that you're going to be adding those together. The other way you could consider it is that you could look at what's the probability of getting no jacks, what's the probability of getting 1 jack, and subtracting that away from 1 whole, which would work as well. In this one, I would probably look at it the first way and go the 3 events added together.
Yep.
If they asked for the probability of at least 1 jack, I would have gone the other way.
Yeah.
I would have found what's the probability of not getting a jack and taken that away.
Well, how about we do it both ways so you can see how it works, and then you can make a decision based on, I would prefer doing it this way.
Yep.
All right, so let's do it the first way. All right, so let's do a bit of diagram. All right, so of course you're not going to write 5 jacks because that's not possible at all. All right, don't fall in that trap because you're going to be having these sort of questions in your assessment and you are not going to think logically that there's 5 jacks in this deck, so I'm going to go 5 jacks as well. Okay, so you need to be careful. Okay, you need to take all these questions logically. All right, so how many 5 card hands can I hold that I have 2 jacks? All right. 5 cards I can hold that consist of 2 jacks. We've just done that. All right. So 4C2 times 48C3. Okay, you've just done that. Right. Now, the other thing I forgot to tell you, yes, that Miss Smith just told you, the word or, so 2 jacks, 3 jacks, or 4 jacks, will require you to do an addition. Okay? So, plus, what's the notation if I have 3 jacks? 4C3 and? No?
47.
Okay.
4C3, yes.
How
Fine.
many cards in the pack are not jacks? 48. Okay, so that's the start of it. That one doesn't change, but how many cards are you now picking out of that 48? You've already picked 3 jacks. 2 left to pick. Okay?
Yeah, see the difference there?
Yeah.
Okay, so it's not 48C3 because you already have 3 cards. If you do 48C3, it means you are going to get 6 cards in total because of the values at the bottom. Alright, how many ways can I have 4 jacks? Out of 5 card hand, have 4 jacks, how many ways?
1 times 48.
Yes, alright, so in other words, following the pattern, 4C4,
Yep.
so NCN is equal to 1, I've already done the proof, okay, time from the remaining 48, because there's no other way we can get a jack, we've got all of them, C1. So that's the other thing, that's the other, so NC1 is equal to N, okay, so whatever N is, so in this case 48, that will equal 48.
Which is a really, really, really important bit when you get to the binomial theorem. It's heaps of fun.
It's a lot of fun. Alright, that's the number of favourable outcomes. What goes on the bottom?
That's too long.
52C5. That's the number of combinations, number of ways you can hold a 5 card hand. Alright, what does that simplify to? So probability at least 2 jacks equals that, which equals what? Digit by digit, please.
2257.
Hang on, hang on.
2257
2257
over 54145.
54145.
Yeah. it is.
Now, before I do the other arrangement, please, and you are listening, all of you, show your working. Do not just write this down. Okay? If you just, like anything else, if you just write that down and it's incorrect, I can't give you any marks. But if you show me some form of evidence that you have approached the question, so these sort of questions would be worth at least 2 marks, 2 marks probably, okay, I can give you 1 mark if you can show me that you understood part of the question. Or you've shown me, yes, this is how many ways you can get 2 jacks, okay? And if you show me this bit correctly, more likely than not, I'm going to give you 4 marks anyway. Okay? More likely than not, I am going to give you 4 marks. Okay? But yes, put this in your calculator, tell me what you get, but make sure this is there. Alright? Make sure your diagrams are clear, that I can see that you are following some sort of pattern and I can see what you're trying to do. If I can see that, I can give you marks. Okay? If I don't see that evidence, I cannot give you any marks. I am not there reading your minds or thinking what you would be thinking now in your exams, okay? Because when you do your HSC, I don't see those exams at all unless I'm a marker and I know your student number, okay? It goes somewhere else, somebody else marks it, they do not know who you are, they don't care who you are, they're just treating you as a number and they're marking all your responses, okay? So that's what I'm getting to, making sure you're always showing you're working. Alright, let's do the other way. The probability at least 2 jacks is going to be the total number of arrangements, take away the complement, which is 0 jacks and 1 jack, divided by the total number of arrangements for the probability. So, there are 52C5 ways you can have 5 cards in your hand. Okay, remembering the order of those 5 cards are not important. Takeaway. So now we need to consider 0 jacks and we also need to consider 1 jack. So how many 5 cards hands can I have without any jacks in them? What's the maths?
48C5. Yes, no?
Okay, so for remaining 48, alright, and we don't have to do anything about the jack because there's nothing there. Alright, so this part needs to be in bracket because you need to do an addition here. Alright, 1 jack. So how many, what's the notation to how many ways I can have 1 jack in my hand? Yes? Times what? Nope.
How many jacks?
4.
How many pickings? 1.
So out of 4 possible jacks you can have, you need 1 of them. Yeah? And then you need, from the remaining 48 cards, you need 4. Okay, so remember the remaining 48 cards are not including those jacks because you want specifically 1 jack. Alright, so theoretically I should get the same answer. Let's check it. Make sure this is in bracket because you are taking away an addition of 2
I
terms.
accidentally pressed off instead of equals. Oh my gosh, that makes me feel so bad. I had the whole equation.
It's over.
Very no.
Right. Did we get the same answer? What's your notation?
It will be the same number.
It should be
Yep.
the same answer.
Let's check it.
Well,
Yep.
So 2257 over 54,145.
yes.
Now, they're doing a complement probability can be very useful. Okay? Can be very useful.
Look how much shorter that was.
And that will, this is one question you're probably in the middle in terms of the working you had to do. Okay? But if this was more one way, so if it was 1 jack or 4 jack, I probably would have done the complement straight away.
Why I
Okay?
said that it wasn't any different is I would look at it and go 1 part, 2 parts, 3 parts in your denominator, and here 1 part, 2 parts, 3 parts in your denominator. You're still considering three things both ways. But yeah, if you come down to no jacks, then it's much, much shorter to use complement than it is to go the other way. And in the more complex ones, you get to a point where you can't, it's really, really difficult to identify a number of different outcomes that meet the criteria. It's far easier to go, how many of them done?
Alright, so that is all the theory notes on permutation combination. Alright, so that means now all of chapter 13 can be attempted, depending on where you've started. But that now covers exercise 13.5. Okay, so you had simple probability, you had the fundamental counting principle, so they're 2 straightforward exercises, and now you get into factorial notation and permutation combination they're starting to pick up. Okay? So, we'll play poker on Wednesday. Okay? So make sure you're here on time, please.
Yes, I will.
Boys, make sure you're here on time.
It's not mine. I was at his house, so it's Christmas.
Okay, you're lucky that I had a few issues. Oh, happy birthday, Kyle.
Oh, thanks. Well, when you said it like, happy birthday, so I'm like, Kyle, happy birthday. Thanks.
What better way to start your birthday than doing a combination lesson?
Yeah.
Awesome.
Alright, so I'll see you period 2. And I'll work out when this will be due, but probably will be after I get back at this stage.
Heaps of time.
Okay, lucky you.
When will the exam be?
Early term 3. Which will cover this, yes.
I'll save it to him.
Oh, I think you should another way at it slowly, not just do it all at once. Because a lot of these questions will be that you will need to come back and re-look at it again. Okay? So don't leave it to the last minute, particularly this style exercise, because it's not always going to be the X, Y, Z, how to approach it. Okay? You need to be able to have thinking about it, and then actually coming back after a while, okay, now I can see how I can do this better. Okay? Do not leave it to the last minute. No worries. No worries.